All right, so still in chapter 18, talking about sampling distribution models. The questions towards the end of the chapter start combining a lot of skills you guys already have, which is just fine. But I just want to make sure I've done some examples so you guys don't freak out. So in 42, says you pay $10 and roll a die. If you get a 6, you win $50. If not, you get to roll again. If you get a 6 this time, you get your $10 back. All right. Well, part A says create a probability model for this game, and in part B it says find the expected value and standard deviation of your winnings. So what's a probability model? What does that look like? What is a probability model? Like a chart, right? It's a table. It keeps track of your outcomes and the probabilities that those outcomes occur. So we're going to define a random variable as your winnings in this game, right? And then you're going to have your outcomes and the probability those outcomes occur. Now we're talking about winnings, so make sure you remember that you're paying $10 to play the game. Okay? So you pay $10 and roll a die. If you get a 6, you win $50. So how much do you really win? 40, because you paid 10 to play. And it says if you roll a 6, you get that. So what's probably that you roll a 6? Okay. If not, you get to roll again for free. If you get a 6 this time, you get your $10 back. So how much do you win? You win nothing, and so how am I going to find that probability? 5, 6, because you don't get a 6. Times 1, 6, right? You don't get the 6, so you get the 6 again. And then other possibility is you lose your $10, and so that's if you don't roll a 6 both times. Right? You guys could do that. That's from chapter 16. Now, part B says to find the expected value and standard deviation of your prospective winnings. So how do you find expected value? Multiply your winnings by the probability. And then standard deviation, there's that big formula. Or you could find both of these by doing what? Using your calculator. So what do you do in your calculator? Right. You have two lists, L1 and L2. And what happens? Stat calc, one variable statistics. And then you make sure that your list is list 1 and your frequency list is list 2. And it should give you X bar in the standard deviation. That's nice. Right? So if you guys want to try that, you can. If not, I've got the answer. Yes. X is the mean, and in this case, the expected value is the mean. So they're the same. So, yes. Calc. Stat calc, one variable stats. List 1 is your actual list, and 2 is your frequency list. So I got an expected value of negative 28 cents and a standard deviation of $18.33. Can someone out there that did it confirm or deny those numbers? You do stat calc what? 1. Okay, so my numbers are good. All right, again, that's something from chapter 16, but you still have to be able to do it. I like our book sometimes, it brings stuff back. All right, now, on C, completely unrelated to this question, like to this chapter, not to this question, to this chapter, but we should still be able to answer it. On the part C, you play this game 5 times. Find the expected value and the standard deviation of your average winnings. If you're playing 5 times, it's 5 separate times. So that's like having x1 plus x2 plus x3 plus x4 plus x5, right? 5 separate times. So how do I find the mean? You just add them together. Negative 0.28 plus negative 0.28 plus negative 0.28, 5 times. So we get negative $1.40. Now, what about the standard deviation? You have to add variances and take the square root, right? Oh, yeah. So it would be 18.33 squared, and you would add them together, or you could just multiply by 5. And you take the square root at the end. So you should get $40.99. Yes? So A, B, and C have nothing to do with what we learned in this chapter. That's okay. It's good to remember that other things are happening. Because remember on the AP exam, they're not going to like separate it all by section. They're not going to say, you remember in chapter 15 of your textbook, if you don't take the square root, you still have the variance. Only with the standard deviation. So you take the square root to get the standard deviation. But we can't add standard deviations. You can only add variances. So you need to add the variances first, and then take the square root. Okay, now on part D. 100 people play this game. What's the probability that the person running the game makes a profit? First of all, it's saying the person running the game makes a profit. So I want to use the information I already have. I don't want to make a completely new model. I just don't feel like it. So I want to use what we have. They make a profit when what happens? We make negative $10, right? So pretty much less than 0. Would you agree? Okay. So keep that in mind because that's what the question's asking. I'm going to write that down. Remind us later. We're looking at probably when x is less than 0. That's when they make money. All right. Part C has nothing to do with Part D. Would you agree? Yeah. Right. So I'm going to erase it so we don't get confused. All right. So what is the mean winnings? Negative 0.28. It's the expected value. Same thing. We're going to use our model to find the probability. What about the standard deviation if 100 people play? Right. 18.33 divided by the square root of 100, which happens to be 10, which makes this nice and neat. It makes it 1.833. Right? Everyone knows where those numbers came from and why we did that. So now we can find the probability, right? But what have we not done? We got to check the conditions to make sure we can use a normal model. I know. Guess what? I don't care if you're hating it or not. It's going to keep happening for the rest of the year. You're going to keep checking the conditions. I'm sorry. So pretty much from now on, if you're using a model, then you should probably check that you can use that model. And that means writing it all out. Sorry. So what are the things we got to check? Yeah, independence, which is randomization and 10%, right? Is this going to be random? Yeah, if you've got 100 people playing and you're playing a dice game. The dice are random. So 100 people playing, it doesn't really matter if there's 20 people playing. It's random because you're rolling die. All right, what about 10%? Well, 100 is less than 10% of people who can play the game. What other assumption do we have? Sample size. And so you got to take a pause. Take a pause. On our mean that we're looking at. This right here. I know. But is it a proportion or is it an average? It's an average. We're talking about means, not proportions. So we can't use MP and Q because we're not doing proportions. We're talking about a mean. So what do we say for sample size for a mean? We say if it's large enough, right? So we say 100 is hopefully large enough. Well, if you think about what's happening, you have this dice game, so it's fair die, so hopefully you're not going to have any skewed anything. You're just rolling a die, right? It should be pretty normal if you have 100 people playing. All right. So we have all this stuff done. We're good with it. It's a normal model, right? It's a normal model with a mean of negative 0.28 and a standard deviation of 1.833. Right? This is standard notation, and that's what that shows. Mean standard deviation. So if I'm going to find the probability that's less than 0, again, we should probably get into the mode of drawing it out, so we just make sure we get points on a free response. Maybe. So we'll say 0 is in there. No, we want less than 0, don't we? Sorry. And what are you going to put in your calculator? Normal CDF and what your boundary is going to be. Negative infinity to 0 with this mean and this standard deviation. And you should get 0.561. There's a 56.1% chance that the person running the game makes a profit. Does that question make sense? It's not that you couldn't do it. It's just stuff we, from old chapters, are putting much stuff together. We okay with that one? All right, we have one more. It involves differences. All right, here we go. Number 53. Suppose that IQs of East State University students can be described by a normal model with mean 130 and standard deviation 8 points. Also suppose that IQs of students from West State University can be described by a normal model with mean of 120 and standard deviation of 10. Of East and West State, not confusing at all. All right, on part A, we select a student at random from East State. Find the probability that this student's IQ is at least 125 points. So that's just normal model business, right? So we have a mean of 130, standard of 8. We're looking for at least 125. Right, that's nothing fancy. We're not doing anything with the sampling distribution. So for your calculator, what's your lower boundary? 125, and your boundary is infinity, mean and standard deviation, so you should get 0.734. That's your probability. Yeah? Yes. Upper bound is infinity, yes. We're right from 125 and above. On part B, we select a student at random from each school. It's just 8 on the A. Okay. All right, on B, we select a student at random from each school. Find the probability that the East State student's IQ is at least 5 points higher than the West State student IQ. That means if I did East minus West, we want that difference to be greater than 5. Right? Agreed? Okay. Well, if we're doing east minus west, we're still not doing a sampling distribution model or anything, but we're combining two variables. So, what is the mean going to be? That's not hard. 10. 130 minus 120. Right? That's not a problem. Right. And then for standard deviation, you don't subtract them anyway. You always add, and you have to add variances. 8 squared plus 10 squared, which is 12.8. Right? So when you're combining two random variables, you can't just subtract the standard deviation. You can't just add the standard deviation. You have to do variances, and so with variances, you always add, and I take the square root at the end. It says these are both normal to begin with, so this is still normal. We just have a new mean and a new standard deviation. So then, in this case, if we're drawing the model, we have a mean of 10 and standard deviation of 12.8. And we're looking for greater than or equal to 5, which is in here somewhere. Right? So in your calculator, you're looking from 5 to infinity with this mean and standard deviation. So I got 0.652. It's not that you guys couldn't do that. It's just something we haven't done in a few weeks, and there was a whole like break situation, right? So to make sure we're reviewing those concepts. Is everyone good with part A and B? Can I erase A and B? All right, on part C then. We select 3 West State students at random. So we have n equals 3. Find the probability that this group's average IQ is at least 125 points. We have a sample size now. Yeah, we do. So, it's still normal though, right? Sample size of 3 is large enough, but it tells you that it's normal to begin with, right? So if you're going to check conditions like you should, it tells you it's random in the question. It tells you it's normal in the question. So the only thing really is it's 3 less than 10% of all students. It better be, right? So we don't have to check everything. They give you 2 of them already. We just need to check the 10% part. All right. With 3, what is the mean going to be of this model? West State is just 120, right? So we're doing a sampling distribution model for mean, so it's just 120. What about the standard deviation? 10 divided by the square root of 3, which happens to be 5.77. Now it's asking us the probability that this group's average IQ is at least 125 points. So if you were drawing it,
are we going to draw the normal model of the quiz?
I want you guys to get in the habit when you're using your calculator to do a sketch.
So sketch.
Not like complex, yeah, but that way you get in the habit, and that way when it's the AP exam, you don't forget. Does that make sense?
Yeah.
And I'm looking for 125, that's like in here and above. Right? So we have a lower boundary of 125, upper boundary of infinity, we have a mean and standard deviation, and so our probability is 0.193. At least according to my calculations, which aren't always right. Okay. Everyone go with C. Yeah? I'm going to leave that there for a second because I need some of part D. On part D, we also select 3 East State students at random. What's the probability that their average IQ is at least 5 points higher than the average for the 3 West Staters? So it's going back to the idea in part B, or difference, but this time we have sample sizes of 3. So we're doing East minus West still, and we want the IQ to be greater than or equal to 5, right? Okay. Well, so the mean of this model going to be? Whatever we got in B, 130 minus 120, 10. Just the mean, right? The mean minus the mean. Still.
I thought it was being,
Right? I mean, we haven't done anything else.
I thought you would multiply by 3.
We're using a sampling distribution model, right? So for the sampling distribution model, the mean of the sampling distribution model is just the mean of our data. All right. Then for the standard deviation, though, you have to find the standard deviation for the sampling model for the east state. We already have it for the west state, right? And then we're going to have to talk about some other stuff in a second. So let's find east states first. What's the standard deviation for east state? 8 divided by the square root of 3, which is 4.62. I'm doing east minus west. I'm putting the other two variables. So what happens with my two standard deviations? Square them, add them, and then take the square root, right? So this is going to be whatever 5.77 squared plus 4.62 squared is, right? Yes, maybe. That ends up being 7.39. So now I can actually find the probability. If I do a quick sketch of east minus west, my mean is 10, standard deviation is 7.39. I'm looking for at least 5 is the difference, right? So you can still use a calculator, but we have a sketch to make it better. And so I got a probability of 0.751. Yep. Is that what you guys got? Excellent. Okay, so is everyone with me here? That I didn't introduce anything new to you today. There's a lot of stuff going on. I get that. There's a lot of stuff going on. So on the quiz, I'm not saying these crazy complicated questions be on there, but you could expect to be able to do one of these. You could do it. But it's combining a bunch of skills. That's the kind of thing that the AP is going to ask you to do. The AP people are going to ask you to combine a bunch of skills. So it's not that you couldn't do it. Just want to make sure we've seen an example. We've done some things. The hardest thing in this chapter, it's not even the hardest thing, you just remember a lot of stuff. You have to think about the question. Are you talking about means? Or are you talking about proportions? Because that makes a difference. It makes a difference in your conditions that you check, and it makes a difference in the formulas that you use, right? So those are some things to think about. 4